dx by itself, then plug everything back into the original integral, replacing the inside function with u, replacing dx with all the junk that you get over here, okay? And then move the constants around, cancel things out so you have a nice clean integral like you have here. Go through the steps of integration that we already know, and then at the very end, just plug back in for x. Let's try another example. This time it's a little bit trickier. Again, now we realize that there's a bunch of stuff going on. We have two functions being multiplied. We have another function inside a function. You don't have the tools to integrate this except for U-substitution. So let's go ahead and try our steps. First, identify the inside function. What do you think it is? Do you think it's cosine? Do you think it's x? Do you think it's x squared? Well, to me, it looks like x squared is inside cosine. Okay, and so to me, I'm going to choose x squared to be my inside function. So we set that equal to u on the side. Then we take the derivative, we find du dx. The derivative of x squared, of course, is 2x. And again, guys, pause this as you go along if I'm going too fast. Okay, and now if I want to get that dx by itself, right, that's the next step, solve for dx. Again, I can just swap the 2x and the dx with each other because it's the same as multiplying both sides by dx and dividing both sides by 2x. You end up with this. Okay, next step. Now this is the trickiest step. You come back over here and we plug back in for dx and we plug back in for the inside function. So the inside function, we want it to be u now. That's the whole point. We want to get this integral in terms of u instead of in terms of x. And so we're going to replace the inside function with u, and we're going to replace the dx with our new stuff over here. And we're hoping to get rid of all the x's. That's the key point here. I want this integral to be in terms of u. And look at how beautiful this example is, where we get this cosine u here, we have our du here, and luckily for us, we need to have this integral in terms of only u, and luckily for us, our x's are going to cancel. Boom! There's an x on the bottom and an x up top, so we say goodbye. And I've got that 2 over there, which I can pull out to the front. And now all we have to do is integrate. The integral of cosine, of course, is sine plus c, which gives us 1/2, because of the 1/2 we pulled out, of sine of u plus c. And then in the end, just to get our final answer, we get rid of u and we plug back in the x squared. If on an exam you don't plug that x squared back in, you're not going to get any credit because u is meaningless. It's a made-up variable that you added. Okay? And that does it, really. I mean, the key here also is that when you come into this step, you need to get everything in terms of u. If your x's don't cancel out, you've done something wrong. You may have chosen the wrong inside function, or maybe you did some of this math incorrectly, but you should have your integral in terms of u when it comes to integrating. One thing that we can do at the end is we can check to make sure that this is legit and that we come back to the original function. So if we take our integral that we just had, which is this, and differentiate it, we should come back to x cosine of x squared. Let's try. Let's use our chain rule skills, right? Remember, the derivative of big F is regular F. Okay, we got to use our chain rule skills. We got this 1/2. That can hang out. That doesn't have to move anywhere. Now we have the derivative of sine of x squared. Okay, that's a chain rule problem because we have x squared inside the sine. We have a function inside a function. The first step is to take the derivative of the outside function. The derivative of sine is cosine. Okay, and we keep the inside thing plugged in. We keep our x squared right there. But then what makes this the chain rule is afterwards we multiply by the derivative of the inside function. The derivative of x squared is 2x. You'll notice the 1/2 and the 2 disappear to leave us with x cosine of x squared. And it disappears because this 2 and that 2 cancel. And we're left with x cosine x squared. So one thing you can do at the end of a test, if you take an integral, you can take its derivative again to check to make sure that you get the same function. And that lets you know that you're right. All right, we'll do one more example because I recognize these are difficult, and I just want to walk us through it and make sure that we have it on lock. This is the last example. The inside function here is what we do first. We find the inside function, and in this case, we've got this 1 plus x squared inside the square root. So that's likely going to be our u. I'm going to choose that. If you made a mistake, maybe you chose the square root of 1 plus x squared to be your u, or 2x to be your u. Okay, that's okay. Don't freak out. Just go back and try again when it doesn't work out. Okay, so on the side, we're going to set the inside function 1 plus x squared equal to u. Then we're going to find its derivative. The derivative of 1 is 0. The derivative of x squared is 2x. Then, of course, we rearrange. We bring the dx up and the 2x down, and that gives us this. Okay, so that's done with our work on the side. We identify the inside function. We take its derivative, and then we rearrange so dx is on its own. Now we come back over here, we plug u in for the inside function, we replace dx with what it's equal to, which is this stuff right here. Okay, and then we hope, we cross our fingers, that all of our x's will disappear and we'll just be left with some u. Let's see, we got our 2x out front, we got our 2x in the denominator from when we replaced dx, we just have a u inside, and guess what happens? Those 2x's cancel, and I'm left with just the square root of u du. And then of course I can just integrate that like anything else. The square root of u is u to the 1/2. 1/2 plus 1 gives me u to the 3/2. And then instead of dividing by 3/2, I can multiply by its reciprocal 2/3. That's where I get 2/3 u to the 3/2 plus c. And then to finish, all I have to do is replace that u with what it is. U is made up, so we have to go back to x. And x, of course, is 1 plus x squared. That's what u is equal to. So we put that in parentheses, and then I just converted it from the exponential form to the radical form. We got the 3 here, so that becomes the 3 here, and the 2 in the denominator becomes the square root. And that's your answer. And if you want to be a really tough and check all of your answers, you can take the derivative of this, and hopefully you end up with 2x times the square root of 1 plus x squared. All right, what you're going to do now is you're going to pause the video, and you're going to try these two problems that you see right in front of you. Okay, take a few minutes for each of them, see what you can do on your own, and then you're going to unpause the video and listen to my explanation. Okay, so go ahead and pause. Okay, so we've unpaused the video now that we're done doing these two problems. Hopefully you actually did them and you're not listening to this. If you didn't actually do them, the computer's camera is looking at you right now, and I'm going to know it. That's a joke. There's no way I can know that. But please do the problems. Let's start with the left one first. The inside function there is 5x minus 4. We take its derivative. That gives us 5 and rearrange. Then we go back. We plug in u. Okay? And we replace the dx with our du over 5. The 5 and the 10 give us 2. Right? 10 divided by 5 is 2. And then we take the integral as we normally would. We get u to the 5th. And then the 5 goes down to the bottom. That's 2/5 u to the 5th plus c. And we can replace the u with 5x minus 4, which gives us our final answer. I went through that quickly. Take a look at it. On the right side, it's tricky what to come up with what's the inside function. I like 1 plus sine x to be the inside function. If you chose a different one, you'll end up in a place where you don't cancel out all of your x's. When you get to this step, there'll be x's chilling out, and then you know you've done something wrong. The derivative of 1 plus sine x down here, the derivative of 1 is 0. The derivative of sine is cosine. Okay? And then you can rearrange that. You get du over cosine is dx. Now we come back up to the top. We replace 1 plus sine x with the u. And we replace the dx with this stuff down here. And we end up with this. And lucky for us, we got the cosine up here. We got the cosine down there. Say goodbye. They disappear. And we're left with just the square root of u. That's u to the, we just did a problem like this. It's u to the 1/2. You get 2/3 u to the 3/2. And then, of course, you just replace the u with the x. With the 1 plus sine x that u is equal to. And I just rewrote it in radical form. So take some time to look at those, and then go ahead and get started with your homework. This is some tricky stuff. Take your time, guys. Okay? So we've learned how to use U-Substitution. Show me you can figure it out with your homework. Good luck.